Hi, my name is Gaurav Pathak and I am here to present my project on quarantine systems at airports. To begin with, I would like to show you a video made by Zurich School of Applied Sciences. They built a simulation to display every commercial flight in the world for a 24-hour period. It does look beautiful, but it's also a cause of concern for me because every flight carries people and with the group of people there is huge possibility of viruses being carried from one place to another. So with this kind of traffic going all across the globe each and every day, the biggest challenge in front of authorities is how do we stop viruses from entering our own country. The question arises, are we prepared? Is the quarantine system is efficient enough to handle this much amount of air traffic? Well, let's take a quick look at quarantine systems at United States. Center for Disease Control and Prevention looks after the quarantine stations at various locations. As of now, there are 20 such airports where quarantine stations exist. At each quarantine station, there is a team which comprises of quarantine officers, and that small group is responsible for the screening of all the passengers coming to that particular airport. Hence, we really need to have an efficient system which will help the current officers to predict which passengers to quarantine for which diseases, depending upon the areas which they come from. So, as I said, the goal is to make an efficient quarantine scanning system to help the current system work better, to gain a better insight into the spread out of various diseases across the globe, to collect, process, and analyze the data using available tools, and also in combining and making use of the data available, which will eventually show the way in creating a full-fledged real-time quarantine scanning system. For the purpose of this project, I have used several data sources. These are some samples from the database collection I have. So this is the global air passengers data. It basically shows the country-wise air traffic across years 2005 to 2010. So the next database I have is TB incidences database. So basically it records the TB occurrences data of per particular country over the span of 2007 to 2011. So the last database I have used is herpes routes database. It consists of so source airports and destination airport codes along with number of stops that particular route has taken. From the data I have of the air passengers across the globe, it seems from the Tableau visualization that the people from United States travel the most, followed by people from China. From the database I have, it can be seen that number of TB incidences in India is highest, followed by China and South Africa. The histograms display the same story. This visualization shows the, the concentration of influenza incidences across the globe. We can see from the map that United States and China have the most number of influenza incidences, followed by Canada and Russia. The histograms also show that in USA and China have the most number of influenza incidents as compared to other countries. But we need to consider the fact that this data will change over the time. By using interactive mapping tool provided by WHO, we can figure out how transmission zone change just over 2 weeks gap. See now it has shifted to Europe from South America, and then it's almost all over the globe. How do we tackle this change? From the reports we have generated so far, we now have some idea of the transmission zones for influenza. So by using VBD Air tool, we can figure out the flights which are coming from endemic affected area or influenza transmission zones to a particular airport. In this case, we can see all the flights which are coming to New York from the endemic affected regions. We can also see the flights coming from an area affected by a specific disease. For example, this report shows the number of flights which are coming to New York from an area affected by malaria. And on the right side of this, you can see the top 10 routes by traffic from disease endemic areas. So there are total 16 airports which are coming from the endemic affected areas. So by using this report, the quarantine officers can scan people coming from this route for malaria. The tools which I have used for this project are FluNet by World Health Organization. It's an interactive information and mapping system. It's used for bringing together for analysis and comparison standardized data and statistics for infectious diseases at country, regional, and global levels. There is also a tool I have used called Vector-Borne Disease Airline Importation Risk Tool. It defines the role of airports and airlines in transmission and spread of human disease. It combines multiple geospatial datasets to inform on the relative risk between differing airports, flight routes, time of year, diseases, and their vectors, in promoting the movement of passengers infected by vector-borne diseases and the vectors that spread this. And the tool which I have used for visualization is Tableau. So, what are the challenges that lie ahead in full-fledged implementation of our system? The first challenge is real-time monitoring of disease outbreaks across the globe, because we now know amount of change happening in disease transmission zones. The second challenge is selecting the appropriate method of quarantine depending upon the origin of the. There may be some situations when flight from particular origin has more than one outbreaks of diseases. And another challenge is to be able to predict the future trend in the disease spread by using periodic data we have. So if we really manage to overcome these challenges and to be able to successfully implement the quarantine system, I believe that it would be very easy for the quarantine officer to successfully scan passengers for disease. For my project, I have used these references. Thank you.